Picture the biggest meat-eating dinosaur you can imagine, a low rumble in the ferns, and then the snap of jaws closing on bone like a steel trap shattering a branch. For Tyrannosaurus rex, that cultural image is accurate. Mechanical reconstructions of this skull reveal a sustained bite force of roughly 35,000 newtons, the equivalent of 3 small cars pressing down through a single mouth. Those banana-shaped teeth concentrated that pressure to 431,000 pounds per square inch. At that intensity, bone shatters and then gets swallowed. Scientists call this bone-eating behavior osteophagy. It is rare even among the most powerful modern predators. Neither gray wolves nor hyenas pulverize and digest skeletons with the frequency of a T-Rex. By studying the mechanics of living birds and crocodiles, researchers confirmed that T-Rex represents the absolute extreme end of the predatory scale, the undisputed benchmark for a prehistoric killer. It is logical to assume every other multi-ton theropod evolved these same crushing jaws to survive. They were enormous animals, often with skulls the size of a human and teeth the length of a hand. Consider Allosaurus. This colossal apex hunter ruled over the North American plains millions of years before T-Rex ever appeared. When researchers modeled the Allosaurus skull, the biomechanical data was unexpected. They found a bite force of only 3,500 newtons. This chart compares that figure to a modern big cat. An African lion bites with roughly 4,100 newtons, exceeding the force of the multi-ton dinosaur. This was a predator with a skull longer than a human torso. Jaws that look capable of tearing a car apart were statistically weaker than a modern lion's. Yet the fossil record proves Allosaurus was a highly successful hunter of massive prey. If it lacked the structural strength to crush massive bone, it must have utilized an entirely different mechanism to kill. An older theory suggested Allosaurus swung its upper jaw down into prey like a hatchet. Mechanical testing eventually discredited that model. The action wasted too much energy and placed dangerous levels of stress on the skull. The true mechanic was more elegant. Scientists identified a strike and tear model, similar to the strategy used by modern birds of prey. Allosaurus drove these serrated teeth into flesh and then hauled backward, opening long wounds to cause massive blood loss. The narrow, light skull was shaped to withstand the specific forces of slicing rather than the heavy impact of a crush. Crushing power is unnecessary when anatomy is specialized to induce shock through rapid, precision strikes. In 2025, a study at the University of Bristol investigated whether all giant predators followed this same evolutionary path as they grew in size. The team used finite element analysis, an engineering simulation method used to determine exactly where structural stress accumulates under a physical load. Researchers ran these simulations on 3-dimensional digital models of dinosaur skulls, testing them the same way engineers test aircraft components. This heat map shows the results for tyrannosaurs. As they grew, bite forces climbed and internal stress rose. They evolved massive, reinforced bone to survive their own power. Allosauroids shows the opposite. They developed lighter skulls that avoided high stress by distributing the load evenly. These animals answered the challenge of feeding a multi-ton body with finesse rather than brute force. Evolution did not converge on a single design. Instead, it supported 2 entirely different biomechanical solutions running side by side. These numbers represent 2 completely different kinds of violence on the prehistoric plains. The bone crusher commits everything to a single catastrophic bite. If it misses the target, it faces absolute failure. The slasher uses a tactical approach, darting in to open rapid wounds and then retreating to let the prey bleed out over time. A third branch, the Spinosaurs, evolved long, narrow snouts to abandon land hunting for slippery aquatic prey. By utilizing different mechanical rules and hunting styles, a single ecosystem could support a vast variety of giant carnivores. These slender-skulled slashers thrived as dominant apex hunters across multiple continents, proving their design was highly effective for millions of years. Modern paleontological discoveries continue to reveal an expanding orchestra of specialized evolutionary designs. The bone-shattering jaw was not the rule of the prehistoric world. It was a rare branch of the family tree. Biological strength is not a single number on a simplified scale. It is a complex combination of crushing, cutting, precision, speed, and ecological adaptation. Like and subscribe to join us for more deep dives into the prehistoric world, and tell me in the comments which creature we should deconstruct next. Evolutionary success is not about building the biggest hammer. It is about engineering the perfect tool for a specific niche.